Hello. Okay, let's come back our start our 352 our digital foreign section. So the topic for today will be related to the recovering data. So we try to looking for some like hidden like scrambling information as well as like some how can the data is recovered. So that's what we try to learn for today. And we try to search for some undeleting data. Also, like if those like damage the drive, is it possible? Can we recover those information from those like damaged drives? So that's what we targeted on. Related to the deleting data. So always like for to those like criminals who are not really like technically like thinking like delete a file can keep will keep the authority from discovery. Most like I say most of people user they will thinking okay maybe they will just like press the delete button or maybe more advanced they thinking they will try to empty their trash bin. Okay, no matter the Windows system or no matter they're using a Mac or some like Linux system. Okay, they think that just if they use the remove, okay, delete, then think they say. So for the expert like the evidence so will be like frequently being deleted from the computers you examine. So like this, if we look at the file system and hardware drive, first thing we need to know like if we need to recover, then we need to know like how it actually for deleting a file, right? How it actually works. So for the OS system, okay, the OS system, so they will use like the cluster, so they will be like one or more sectors. Okay, this one is the pretty old disk. If you look at the latest will be SSD, then they will have like even their different slot right section, kind of the same idea. So when the file system, they will view this the cluster, so they will like also say as one or more sectors. And for the hard drive, they will divide it into like the sector like 512 byte or like 4096 byte like this. Okay. And when they deleting, and we need to know like maybe now for old version like legacy, if you did try to reinstall your system or like look at it. So for the system, we call the legacy will be like beyond like Windows XP or 2000 or like OS 8 or before, okay. Or current, like more latest will be Windows 11, 10 or some older or Mac OS or above. So that's how it looks like. And before for the Windows system, they use like FAT16 or FAT32. So it's like pre-Windows like 2000 version, and then they changed to anti-FSS for the file system. So using for the Windows like after 2000, even right now Windows 11. So if you look at your if you're a Windows user, if you look at your Windows format, like when you try to look at the format, it should be anti-FS. Okay, and they use the table to map the files to specific custom where they store on the disk. Okay, so like this is how the system it looks like. And when they store the file, like in the Windows, like in old time, like FAT or FAT32, or you may imagine it if you know the USB. Okay, the USB also using sometimes they're using FAT or FAT32. So they will record the cluster, the number of the next cluster, so they will know the next one, and then they will add the called the NOC, so end of a chain. So if they really like count end of it, and we the system will try to mark like maybe some like back section or like reserve section or some open section, so related to all those like cluster. So that's how it actually works. Okay. When we actually deleting a file in a Windows system, okay, so when we really delete, we are not really, here is really key concept why we are able to recover or sometimes it's not able or not possible to recover. It's like the data not, actually they're not removed from the disk. Okay, this is how it works. So the fetch is updated, so they reflect the cluster they're no longer in use. And then the new data can save to those like cluster. So maybe overwrite the old information. So here is really key concept. So if you are going to delete a file, no matter is the way nowadays a Windows system, even your phone, like cell phone, maybe iPhone, Android phone, or if you are using the Linux system or the Mac, okay, wherever. Because once we update the headers like the section storing, so they allow those sections like the cluster like allowed to overwrite, then we can just waiting for next time. So they're not protected, they're not allowed to like return. Okay, then we know we store something. The advantage is like why we need to know the mechanism, because we try to reduce the frequency of read write. Okay, so if you are not going to, if you, let's say if you delete old information, okay, so if you, okay, let me rewrite a bit, maybe from like 100 change to R0, okay, and then we wait for next time for writing a new file. Of course, it would be more clean, right? But you're thinking, okay, you already have one more time that you have wait, even though nowadays if you are using SSD, so they have a limiter, they have a bit wide life cycle. Okay, so they're limited. So if we don't want to waste it and extend the life for the hardware, then we try to reduce the read write. Then here's the reason. So we only update those cluster that are no longer in use. Then they're allowed to update. So no matter is the fans or NTFS. So NTFS like fundamental files, including the MFT, so it's called master file table. So it will also have same idea. We will describe the files on the volume, and then they have another one called the cluster bitmap. So they have a map of all the cluster on the hard drive. Kind of same idea, even though we change from hard drive to SSD, so it will be using the same format. Okay, same design of structure. So for the MFT, so the MFT, the file, a master file table, so we connect the one base file. Okay, the record of each file's directory, and then it will serve as same like purpose as fetch. So it's same idea. So working. So for the custom bitmap, we'll try to match all the custom on the disk. So then how can you? So through the file table, and then we can match. So if you want to search for a file or a certain folder, so we can through this table and then go to the directory and then match with their bitmap, and we know which exactly which cluster and then on which section on your Windows system. So when a file is deleted, so they are not really actually removed from the disk, and those the cluster, so like or those section below, they mark as a delete or like move to the recycle bin. Okay. Even though you say it's under recycle bin, it doesn't mean you are actually deleted like empty. So once you really empty your recycle bin, like even the apples, then they will mark as like fully available. Okay. So if you check, if you try to delete a file, they keep in your recycle bin or like the trash bin in your Mac or Windows, your volume, the storage, it won't reduce. Okay, because it's still occupied. But once you like try to empty it, so the storage will become like available for you to use it. And those like file names in the MFT, they're marked with a special character. It means that file has been deleted. Okay, so delete. That's how it works. And here we're going to introduce that some software, so help us to recover the files. And of course, we later in our lab, and then I will let you to try, and then we cover the files. And just like kind of like summarize the idea, so you know, because we know like no matter Mac OS or Windows, even though we say we delete a file, empty our trash bin, recycle bin, it does, we just like try to mark it. Okay, the file already deleted, but actually the actual data stored on the SSD, they are not really erased. Okay, so if we know certain file, they were files that were stored in certain cluster on certain section, then we are able. So like if we read it bit by bit and then knowing certain length, then it's possible to recover all the data. Okay. So here's have some screenshot like how it looks like. So this sticker, so it will try to like you can choose the hard drive, and then after you choose the hard drive, you can just start the data recovery. So you can have a dig deep or deeper. So it may, of course, like they will try to scan your file system, and then they will see, okay, for those, and then they will list all potential all the files and you can recover it. Of course, there's so many recovery software like application we can use. And this one is one of the example. So after you like choose this one, and then if you choose then go to next, so it will try to recover an individual file. So it will list all potential files away. So there may be some JS file, some HTML files, some time like possible, some image file. So all of them, they are available. And then win and delete. So it's another one. So easy to use, and vice driven. So it's another one. So you can choose your this as a step one or some like image file. So later we can like try. And then after we choose it, so do you want to like check all the file type, or if you're looking for specific file, like let's say image, documents, or anything, if you want to like check everything. And step 3, so you just like looking for the folder. So you want to like select it, and then you can just like save it, so it will execute and run. Okay. And free and delete. So another one for the personal use. And when you open it, and you will see showing it list the drive you have. So sometimes like your if you have the portable, like let's say you have fundable let's say the USB, and also you can try to recover if you have some like SD card, micro SD, whatever like this, then we can try to recover. So we can choose it from your drive. Okay. So after you choose it, then we can like choose any file type. The same idea, then it will going to scan. So you just like select the drive and then click the scan button. Then you are able to recover it. Also the another one, the OS forensics. So it will be the robotic forensics tool. So also it's provide for the undeletion. So for the undelete from like those mount image or some like a live system. So how it works. It looks like it even looks like pretty old UI, but it's still like, first of all, you can create some looking for some like DV file search. And then when you click on it, then you're going to like search. It's slightly blurry, but you can similar. You can see it will list all the result, even for the Linux system. Okay, first then we have the ext3 or ext4, and when we store the file in Linux, they will contain a block. Okay, and those blocks sometimes they need to be like extended, and then the exercise of block they will depend on the parameter used. So when we with the comments like create the partition, so we have the inox or some like soft link. If you did try to work on the Linux system to allocate your the drive, so you see the /d dev. So sometimes that you will see the drive. Okay, or that include if you try to pop in the USB, so you will see more like the drive pop in. Okay, so all this will be able to list, and they will be have a continuous continuously block. Okay, so it depends on, and we can use the method like the unknown hard link, the integral, or the unknown links like directly for some like certain specific file, right? So it will keep checking, because for Linux OS, no matter you bring Debian Arch or others, so they will have a kind of reference to each hard link. So if the reference can't reach 0, that means the file is deleted. Okay, so if we need to recover a file in a Linux system, so we just need to like move the system to single user. Okay, and then with the initial like one command and then try to reuse the grid. So we try to search and recover the file. So we can like looking for like grid something, and then maybe what kind of like the keywords process, and then if I say the DEV, okay, maybe SAD2. So it's one of the extension we choose, and we output all the files in this like text file, txt. So it's how it looks like. Also, we have external delete. So it's kind of like similar. We work on both like ext3, ext4 partitions in the Linux. Okay, so we can also use it for. We mainly rely on is like the shell command. So we can restore or delete file from like SDA partition like this. We can restore. So here's like one of it scalpel. So this one is another maybe you see before we mentioned about this. So it works on Linux or Mac OS. So we can use to compile the source code to work also in Windows. Okay. So after we install it, and then we can verify the output directory, send it, and then we can edit the config files and run the scalpel commands. Okay, commands, and then we can let it to search our folder directory and get a recover it. So that's what we did before. So we can like execute, and in our laboratory in our lab exercise, then we'll try to let you do it. And for the Mac OS from later, so they were based on the FreeBSD. So it's a more like Unix clone. So kind of similar to Linux system. And for Mac OS, we used before the HFS as a hierarchy of file system path, or sometimes earlier version they use the HFS, some are general. So it's slightly changed. If we need to recover the Mac, maybe we have got the Mac keepers, so we can recover it. And so we just like same idea. So we can open the file, open it, and then select the volume. Maybe you have two partition or one partition, and then just like select the undelete, then you are able to do that. And if we need to recover from information from the damage header, then we need to check. Okay, so we maybe like remove the drive, connect to the test system, boot the test system, and then try to copy the file from drive to the test system. So that's like how it looks like. If you have a damaged hard drive, sometimes maybe the header, okay, maybe the OS system, okay, they crash. Okay, that means that you couldn't boot into your system directly, but it doesn't mean all the data lost. Okay, so if we can create a test system, okay, and connect to it, and you just like make the, if you remember, we have one is the volume. If you remember the USB volume, we copy it and try to search for data. That's how we did before, like how we recover the data to search for data in a USB file. Okay, and the everything based on, we say that we recover from the damaged media. So only one thing is that physically not damaged. Okay, if they are physically damaged or lost certain bit, sometimes you see the checksum or like MD5 or SH1, SSA256. If they are not matched, then of course if the file crash, then we have no way to recover the files or some data. Okay. So after we remove like the drive and then connect to our test system, we put into it, and let's see. Okay, sometimes they will the drive may be not recognized. Okay, so if they're not recognized, maybe off you maybe pretty much you did experience this one. Like if you try to plug in your USB or somehow your portable drive, there was I say crash. Okay, especially switch from Windows to 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 Mac OS, or Mac OS switch back to Windows. Sometimes it crashes, or when you open certain file, you forgot to eject it or terminate the application. It crashed because when you open the file that had the you see the mapping they are like overlap or crashed, then they are not able to get. Sometimes they try to like scale one more time perform the repair. If they are able to repair, then we can try to execute to get some maybe image driver content like this. So we are able to get it. And if we more advanced, like more like local repair, like advanced, so we need to like replace some printed circuit board. Okay, and then maybe we need to replace some right head assembly. So if for hardware, okay, we have the header. So if those like we maybe try to use some circuit board, bypass it or replace it. So let us be and then we can transfer this printer to the heavy drive like this. Then we are able to read it. So it's also another possible way to recover the drive. And after we like recovering after logical damage, okay, so to the logical damage, so we can like prevent some like from the OS. So maybe mounting, you're using the file system. So those like logic may cause some system crash or data loss. And also sometimes the power outage or when you turn on machine where it's like putting or shutting down. So anything when you're executing. So when we try to load the data from the drive SSD to memory, right? And then the CPU is executing. So maybe the sometimes the maybe the NTFS on the Windows or on the Mac. So when they're executing, they had the sessions maybe it's updating or not yet updated or somehow like this. So when you terminate suddenly, okay, maybe because the power outage or you forgot to eject or the conflict between the application or management of the OS, then cause a crash. That would be cause all this problem. And perhaps somehow we have some way to check for Windows, we have a check disk and Linux F disk or these utilities. So more we can like to scan it. And always, how can we prevent the logical damage? We can try to like generate the file system and also use a consistency checker. Also use this controller of the battery backup like this. So we can this one prevent the sudden power outage and then make sure when we make sure we try to like save open the application over everything right, they are consistent. Okay. And for consistency checking, so maybe like they try to scan this logical structure, so ensure they're like consistent with its specification, and then maybe they will try to verify the dot or like dot entry point to the correct directory. So if you know the dot or go back the primary directory, okay, or the checkers include like checklist or F scan like this. So they will have a similar function. Sometimes I'm not so sure how many of you have experience to try to recover the disk. Because to me, I did try to do it like sometimes having my friend. They most of the time will be the Windows like they crash, okay, or USB. So if you are able to recover like clone the data and then format it, and then you kind of like pretty high percentage able to recover it. But only one thing is that if they have bad setter or a bad clusters, that means like that certain area like physically damaged or not able to read, then we have no way to recover it. And for the consistency checking problem, it can fail in the file system. So if they're really highly damaged and check this, they may delete the file. They're already out of place or unexplainable. So it's also possible. So sometimes powerful can help. It's kind of like the steps that you can help you to format, recover, or to scan. Okay, but if it doesn't work, then it's really hard. Then maybe we need to work on like physically, like change the headers or those like hardware to read the data directly. Okay, and we have let's always assume we have the zero knowledge analysis. So just like few assumptions make about stage of file system and try to scan the drive and then try to match the result to spec. So we always scan all drive and try to match it. So we try to grab it. And you will see this keyword, we have the file crafting. So that's what we did something before. So the file crafting, the file, they only partially recover. And it works always on any file system. So I wish that when we look at this one, then we call that our previous lab you did. So think about what we did before. And it's like we used to recover the data from the this, and there would have some damage or somewhere file itself is corrupt. Okay. And those like utilities. So we try to look for the file headers or the footers, or sometimes pull the data from between two boundaries like this. So the portable tool is the scalper. So I think you already download it, and we try to use it this one. And our previous lab is from the DD. If you see the last one DD, so I will keep it for our next lab also with other step too. So on the Tuesday, we have talked about the steganography. So that one is like how to hiding certain bit, like hiding the files into another file. Okay, and later we'll come back. So we'll mention this one, and then after we'll go back to recovery about the DD. So the last part of our previous lab. Okay, so far we will talk about how can we undeleting the data. Then we you need to know why we are able to recover, because sometimes for deletion is not completely deleted. Okay, so once the data originally they stored on certain cluster on those sessions, they never being overwritten. Okay, then they are possible to be recovered. So we are able to recover those information from damaged drive. And that's it for recovering for this lecture. And thank you.